So we're going to review how to multiply fractions first before we get into rational expressions. When I'm multiplying a fraction, what am I going to do first? Is there anything I can reduce on this? No, there isn't. So what I'm going to do is multiply straight across. This will be 2 times 1 on the top and 3 times 3 on the bottom. So it'll be 2 over 9. Okay? Little review. On the second part, what I want to do is there's 2 different ways we can do this. We can break these down into their prime numbers, and that's what I want to do first, okay? So 2 and 3 are already in prime numbers. I'm going to leave them as they are, okay? And I'm going to actually break down the 6 into its prime numbers. What are its prime numbers? 2 and 3. And what is 8? 2, 2, and 2. Okay, you can use the factor tree to find that if you need to. Okay, so notice that I've already put them together here on one line because I'm multiplying straight across. Now, look at the top and look at the bottom. What can I cancel out? I can cancel out a set of 2's here, a set of 2's here, and a set of 3's. Okay, so my answer on this is 1/2. Any questions? Here's the system that you're going to use for evaluating multiplying rational expressions. First of all, you're going to factor everything as far down as you can. Okay, step number 1. Step 2, you're going to simplify it by crossing out like factors from the top and the bottom, the matches from the numerator to the denominator. Number 3, you're going to multiply them out. So, for the example here, I'm going to break it down into its prime numbers again. And I'm just going to have one bar here for the fraction because I'm going to put everything on the top in the top bar, everything on the bottom in the bottom. So 8 breaks down into its prime factors of 2 times 2 times 2. What are the prime factors of 16? Well, if I have to, here's my factor tree. 2 times 8, right? 2 times 4. 2 times 2. So I got 4 2's. So I'm going to keep making some 2's here. And then I have 1 p. Okay, on the bottom, 14, the prime factors of 14 are just 2 and 7, and I have a p. And then 2 is already a prime factor in itself. So, what can I cancel out here? I have a set of 2's here, and I have a p here I can cancel. I have another set of 2's I can cancel. Okay, so if I multiply all these 2's out, it's 2 to the 5th or 32. And then on the bottom, I'm left with just a 7p. So on this one, what we're going to want to do first is break everything down, once again, into its prime factors. And right here, a 9, I can break that down into 3 times 3 times x. The x plus 7, there's nothing I can factor out of that, so I'm just going to leave it like that. But what can I factor out of the numerator here? A 5. So if I factor out a 5, I'm left with x plus 7. Now, what can I cancel? X plus 7. Okay, so if you think about this bar being all the way across, is there anything else I can factor out? There really isn't. So 1 times 5 is what? 5. And then 3 times 3 times x is 9x. So that's my answer on this one. We want to do the same thing with this one. I'm going to look at the numerator here. First of all, I'm going to make my one fraction bar. What can I take out of 6v plus 12? A 6. So 6 times v plus 2. Now, is there anything I can factor out of the 5v squared minus 44v plus 32? There's not really anything I can take out of that. So what I'm going to have to do with that one is use my box method. So I have a 5v squared here and a 32. I'm going to multiply 5v times 32, and you get 160 v squared by doing that. So I'm going to give you guys a moment to think about what are the factors of 160 v squared that would add up to be negative 44. So think about that for a minute. So our factors are negative 40v and negative 4v. So I can put those in either of those two boxes. I'm going to put negative 40 right here and negative 4 here. I can factor out of the top row here a 5v, and out of the bottom row, because remember we had they both have to be negative second terms in the binomial, this will be a negative 4. My left column is going to be a v, and my right column is going to be a negative 8. So I'm going to replace this whole trinomial here with those two binomials. It'll be 5v minus 4 and v minus 8. Now, what can I factor this 9? How can I factor that down? 3 times 3. And notice I could even factor the 6 down to 3 times 2, right? So I'm going to take that and make it a 3 times 2. What can I factor out of this binomial right here? A 6. So I'm going to take that 6 out, and I'm left with v, actually 5v minus 4. And notice there's a 6 here. I can factor down to 3 times 2 also. So what do I have in common? 5v minus 4 I can take out. What else? Yeah, I could take these out, this out. So is there anything else that can cancel? No. So I'm going to be left with v plus 2 times v minus 8 on the numerator. And on the bottom it's 3 times 3, which is 9.